Hello class, I'm here to talk about the remaining problems for chapter 8, as the first video was quite long with all the details I could give you. Right now I'm just going to go straight to the point and answer the questions for problems 14, 16, 18, 20, 22. If you're not sure, then just go back please to the first video, and that should clarify a lot of the calculations I'm going to be doing here. Let's start with the problem. Use the following information to answer the next 10 exercises. A sample of 20 heads of lettuce was selected. Assume that the population distribution of head weight is normal. The weight of each head of lettuce was then recorded. The mean weight was 2.2 pounds with a standard deviation of 0.1 pounds, and the population standard deviation is known to be 0.2 pounds. Well, from here I can see lots of questions answered, so let's go straight to the point. First of all, identify the following. Where's my average? Where's my mean? Let's see if we can find anything. Assume. Wait, let me see if I can find a specific word. The mean weight. So we are working with pounds. The mean weight, there is the answer, was 2.2. So my average, my mean, is going to be 2.2. What is my standard deviation of my population? Not the standard deviation, the sample. The standard deviation, the sample symbol is just the small letter S. The population, here's the symbol. The population standard deviation is known to be as 0.2 pounds. What is my sample size? N for sample, a sample of 20 heads of lettuce. 20 heads of lettuce, 20. So we completed 13. 14. In words define the random variable x. Well, in general, we're talking about the weight of heads of lettuce, or you could say the weight in pounds of heads of lettuce. So let's go. In general, you're talking that x is the weight in pounds. Of a head of lettuce. That's the subject in general, okay? 15 words define the random variable x, the average. So what are we really using here? So let's go back here quickly. A sample was selected. The weight of each lettuce was then, the mean weight was 2.2. Okay, so let's say that my x bar, which I can go ahead and do, put this symbol here, x bar. So my average or my x bar is the mean weight of a sample of 20 heads of lettuce, right? 16. Which distribution should you use for this problem? Well, if you haven't written any further, you would say probably a t distribution because it's less than 30. However, you have both standard deviations known. Not only does saying then the population standard deviation is known to be, so right there it's a z table. Okay, so we know for z table and is a normal distribution with a z table. So right here, if you remember from the previous problem, okay, we're gonna be just saying then that, let me put it over here. So my x bar, or my this distribution, okay, it's gonna be a normal distribution. My mean of x is 2.2. My standard deviation of population is 0.2 divided by the square root of my sample size, which is this formula down here, okay? So there we go, 17. Construct a 90% confidence interval for the population mean weight on the heads of lettuce. State the confidence interval, sketch the graph, and calculate the error bound. I have sketched the graph before, so here they are, but let's just see what they really mean. So right here I have my confidence level, and here's telling me that my average is 2.2, And for 90%, it says that my lower bound should be 2.13 and my upper bound should be 2.27. Therefore, it's telling me my confidence interval should be between these two. So let's see if that's correct. So 17, how do we calculate that? Well, we go back to this formula over here. Okay. And also, I have explained all that before, which I don't want to go too long on this. So 90%. Therefore, for it, we have 10% area divided by both tips, 5% on this side, 5% on this side. So it's a 95%. 1 minus, so we go right here, 90%. It's going to be 1.645. Okay, so 5% on this side, 5% on this side, it's gonna be a 1.645. So the way we do this, we're gonna do equals to, let's start with the error bound margin only. So it's just this portion right here, okay, which is gonna be really my confidence level, 1.645 times my standard deviation divided by the square root of my sample size, and I'm going to close it here. Gee, excuse me, sneezing. Okay, so we got our error bound margin, okay, which we have gone over this before over here. So you have to do for both the lower and the higher. So right now, I just did the error bound margin, okay? So now we're gonna do the actual confidence interval. For the lower, you're gonna have to do your average, then for the lower, minus your error bound margin, and for the upper level, you're gonna do your average plus your error bound margin, which confirms the information we have on this graph right here. So at 90%, my error bound margin is around 7%, which you can go ahead and make this smaller. My confidence interval then is going to be 2.13 and 2.27, which I have right here a graph for you. And now we're going to do 18. 18 is asking to construct a 95% confidence interval for the population mean weight of the hazard lattice, and same thing, state the confidence interval, sketch the graph, calculate the error bound. So at 95%, 1 minus 95% is 5%. So for each tip of the bell curve, we have 2.5% here and 2.5% here. But since I already went over this and explained, we'll just go and cheat over here on this little table. Set 95% is 1.96. The fastest way is just to Control C. I'm copying this. I'm gonna Control V. I'm gonna paste right here, and I'm gonna modify. Okay, so right here, I'm just gonna do now that is gonna be for 95% is 1.96. Nothing else is gonna change. So my error bound margin now is 90% instead of 7%. Right here, I have to correct, because if you remember over here, I refer to this over here, so I have to fix it. So it's gonna be average, average, I'll go back. My average, okay, let me try this again. Here we go. Okay, and then same thing here, my average plus. So for my lower bound, it's gonna be 2.2 minus the 9%. For my upper bound, 2.2 plus the 9%. Here's my error bound margin. Here we're gonna fix it. 11, 29, and which I graphed for you before and confirm my values right here. One thing I noticed on the next question is incorrect. It says incomplete sentence, explain why the confidence interval in the 17 is larger than the one in the 18. Actually, that question is incorrect. What they are trying to say is, if you do this interval here, so if you do 2.27 minus the 2.13, you have 15 points in between right here. Right here, if you do 2.29 minus 2.11 is 18. So you can see the confidence interval, and you can even look at the pictures. I mean, I try to put as closer I can. You can see how the confidence interval area right here is actually larger than the 17. So this question is incorrect. It says why the confidence on this problem should say is larger than this problem. Well, the answer, if you would do the other way around, would be the interval is greater because the level of confidence increase. Remember, this is 90%, this is 95%. Okay, so if the only change we made in the analysis was the change of confidence level, then all we're doing, we're just changing changing the area for the normal distribution. So a larger confidence level results in larger areas, larger interval. Okay, let's see if that makes any sense. Remember what I said before, I increased my confidence level. Now I'm more confident. Here's 95%, right? So now, to be more confident on my answer, I have to allow more room for error. So yes, I did put, so let's say that I tell someone, you know what, I went to this place and this Diet Coke, can of Diet Coke cost, I don't know, it costs somewhere between a 2.11 and a 2.29. Of course, you're not going to talk like that. It's just an example. So let's say you get there and it's about right here, is a 2.14. Well, you are, pretty confident that you gave such a larger area that it could fall within any of these values. The more you narrow this, then your confidence level diminishes because you could possibly be the fact that being wrong or your error bound margin could be higher. You could, the more you straight these values and you try to get closer to the actual value, the less confident you are. Your level of confidence is not as high. So the more you increase your confidence level, the more you have to increase your sample, your area to be correct. Okay, so 19, we did 19. Okay, so 19, let's say that the interval is greater on 18, that's the correct, because the level of confidence increase. We could say we are allowing more room for error. Therefore, we can be more confident or increase confidence level, which results in larger areas and larger intervals. You can type. If I do this, probably gonna mess up. Yes, I realize that. Okay, so let's see if I can just wrap. Nope, like that, and like that, and like that, that. Okay, better. Okay, 20. We're almost done. Incomplete sentence give an interpretation what the interval in 18 means. Okay, so 18, so it asks for 90%, so we can, so let's say, let me copy this here so I can have the same format. I don't have to go through all that. So it's gonna mean the 90%, 95%, right? So we can say with 95% confidence that the population mean of the weight of heads of lettuce is between, what is it? I'm looking over here, 2.11 and 2.29. Okay, 21. Let's do 21. Over here. What would happen if 40 heads of lettuce were sampled instead of 20 and the error bound remained the same? Well, right here, you increase your sample size. So if you do remember from the central limit theorem, the more you increase your sample size, the closer you're going to get to your mean, right? And also, if you increasing your sample size, you could increase your confidence level higher because now you have more room for error. And since it says it's keeping the same error bound, since you're allowing more room for error, we can say that the confidence level will increase. That means you have more room for error. And now 22. What will happen if 40 heads of lettuce were sampled instead of 20 and the confidence level remained the same? So let's say that we didn't change the confidence level, but we're increasing the size, right? Which gets closer to the mean. But if we keep the same confidence level, really what it will happen is the confidence interval would become narrower. You know, you want to prove that? Like over here, let's just use this first one right here. Let me change my, let's copy right here. And now instead of 20, let's do 40. Look at what happened. My error bound margin, now it decreased, right? So now let's do the confidence interval. Let's do this minus this. And let's do this plus this. Can you see now? Let's do the upper minus the lower. Now we went from 18 to 10. Can you see how my area now it's gonna be so to 15 to 25. So about right here, let's say that we have wait, okay, and then let's copy this one, let's paste, and let's put it over here. Can you see now how my area now it's smaller, right? But if I would keep the same error bound margin, I have a bigger sample. Therefore, it gets closer to my mean. So that means my confidence level actually increase. And then it would be done with problems 14 through 22. I hope this helps a little. And as usual, let me know if there are any questions. Thank you.